Solve the following inequality. Write your solution in interval notation. All right, so I want to know where a cubic, x cubed plus 9x squared minus x minus 9 is greater than or equal to 0. And usually when we are factoring a cubic, what we want to do is graph it, get initial rational zeros, and then factor those out with synthetic division. But if there's 4 terms and what can possibly happen, it doesn't always happen, if you separate those first 2 terms from the last 2, if it just so happens that you have the right kind of coefficients, then what might work is if you take out a common factor of the first group, which would be x squared, and that would leave me with x plus 9. And if I take out a common factor of the second group, which is a negative 1 really, that would also leave me with x plus 9. And the cool thing about that is the x plus 9 is now a common factor of the remaining 2 terms, which I can factor out. And that leaves me x squared from the first term and negative 1 from the second. And then x squared minus 1 could be written as x plus 1 times x minus 1 because it's the difference of squares. All right, so the zeros that I have to work with here are negative 9, negative 1, and positive 1. So what I'll do is put those zeros on a number line in order and choose some test values in each interval. So on this interval, I could pick negative 10. Here I could choose a negative 2, 0 on this interval, and then positive 2. And what I'll do is I'll plug this into the factored form of this polynomial and see if the result is positive or negative. So if I plug negative 10 in, that's going to be negative 1 times negative 9 times negative 11. So it's a negative times a negative times a negative. It doesn't matter what the actual result is. The final answer is going to be a negative number. That's all that really matters. On the next interval, if I put negative 2 in, negative 2 plus 9 is positive. And actually, I'm just going to write that. So positive. Negative 2 plus 1 is also positive. Negative 2 minus 1 is negative 3, so that's negative. So one negative in the group, that will stay negative. And you all probably caught this, but it looks like I actually did make an error here. I'm thinking negative 2 plus 1 is actually negative 1, so this should have been a negative. So a positive times a negative would result in a positive value. 0, if I plug in 0, this would be 0 plus 9, which is a positive number, 0 plus 1, which is also a positive number, and 0 minus 1, which is a negative number. So everything in that interval will be negative. And if I put 2 in here, 2 plus 9 is 11, so that's a positive number. 2 plus 1 is 3, which is positive, and 2 minus 1 is also positive. So everything on that interval is positive. Now, I want to know where this thing is greater than or equal to 0, so I'm looking for intervals that are positive. Because it's greater than or equal to, I would include any of the boundary points. So I can go ahead and put solid circles on those. And the ones that are greater than or equal to 0 are this interval right here and this one right here. So the solution is going to be the inclusive interval from negative 9 to negative 1, then union to join 2 sets together, 1 to positive infinity.